Welcome back. Today we're going to go over translating real-world expressions. In order to do that, we have to know a couple of things about how to translate expressions. So first off, expressions are frequently used in real life to describe situations involving comparisons. Now when we have this type of translation, we need to make sure that the expression is asking the same thing that the words are saying. So first off, what is being compared and what will the variable represent? Okay, so with that information, it says here we're going to write an expression to represent the comparison below. Simon has 4 more cookies than Lucy. So we have to do 1A, Lucy is represented by what? And then B, how can you explain the number of cookies Simon has compared to Lucy? So starting out, if we read the information, it says there that he has 4 more cookies than Lucy. So that tells me that if we have Lucy, we can just represent her by L. And you could choose any variable you want. I just chose L because it's the first letter of her name. Now for Simon, it tells us that he has 4 more than her. So to represent Simon, all I'd have to do is say Simon equals Lucy plus 4. Now normally I wouldn't write out Simon this way, but I'm just going to show you it like that. I would probably have a variable for Simon and say that S equals L plus 4, or even I would just have it L plus 4. So there are a lot of different ways to represent it, but that's just to help you not necessarily be confused on what that is actually equaling. Number 2, Gary weighs 12 pounds less than Jeff. So Jeff could be represented by the variable J. And how can we explain the number of pounds Gary weighs compared to Jeff? Well, it says there Gary weighs 12 pounds less than Jeff. So I would go ahead and say Gary is equal to Jeff minus 12. Right, so variables, they should be there to represent part of the situation in which you're given the least amount of information. So we don't know some of these pieces, and since we don't know them, we go ahead and just include a variable. So breaking these things apart, we go through and look at number 3 here. It says that the width of a box is twice as long as its length. So I need to define a variable, I need to represent the length, and I need to represent the width. So looking at this scenario, I could define any variable I want. I'm going to go ahead and define the variable L. And L is going to stand for the length of the box. So if L stands for the length of the box, how can I represent the length? Well, I can represent the length by just putting L. Now I could represent the width as W, but in solving equations and simplifying expressions, we don't want to have different variables to describe similar things because we can't compare them. We need to have it to be the same variable where possible. So there has to be a way that I can represent width by using the variable that I've already chosen, which if we look at this, it says width of a box is twice as long as its length. So if I just take the length and I double it, then I have a width. So 2L would be the representation of the width. Let's try that again. Number 4, it says 80 brownies were sold here at the bake sale for half, and were half the number of Rice Krispie treats sold. So if I take that information, I need to define a variable. So I'm going to go ahead and pick Rice Krispies. So R equals the number of Rice Krispies sold. And then in order to understand that, this first one, it says it represents the number of brownies. Well, I've already defined the variable for Rice Krispies, so I'm going to represent Rice Krispies by just writing R. Now if I have that as R, what would brownies be compared to R according to this information up here? Well, if we look at it, we can see that the brownies, if they were sold, they were half the number of Rice Krispies. So however many Rice Krispies I sold, brownies were half of that. So if I sold 5 Rice Krispies, that would be 2.5 brownies. If I sold 20, Rice Krispies, that would be 10 brownies and so forth. So I would just represent that as Rice Krispies divided by 2 or times by a half. Okay, next question. We have to complete the table below to explain a couple of things just like we've been doing. So it says there Allison sold 12 more boxes of cookies for the fundraiser than Evangeline. So I go ahead and define my variable. I'm going to define it as the number of boxes that Evangeline sold. And then we have to represent Allison and represent Evangeline, which in this case we already did. We know that hers is the variable E. And comparing Allison, it says Allison sold 12 boxes more. So that means I would take that information and say E plus 12, because whatever Evangeline sold, Allison will have sold 12 more. Okay, number 6. Xavier has 85 on his math test, and that was 37 points less than twice the grade on his English test. So if I were to define a variable, I'm going to go ahead and define this variable as E, which is going to be the grade on the English test. And then I can represent the English test here with the variable E. And now doing a comparison for the math test, if I look at the information up here, the 85 is some cool information, but it's not something that we need. What we need on there is that we know that his math test, it was 37 points less, and it was less than twice the amount of score that he got on his English test. So if I take my English test score and I double it, that means that the score that I got there, his math score is going to be 37 points less than that. So we would take 37 points away and we would double his English score. So we have 2E minus 37. We're doubling the English score and subtracting 37 from it, and that will be how many points he earned on his math test. Right, number 7. We take this information here, and it says it costs $100 to rent skates, or to rent a skating rink, and it's $8 per person. So first off, defining our variable here, I think it's really important to define that we have the number of people that are going to be in this. So I have n equals the number of people. Now, whether you rent this skating rink for an hour, or you rent it for 5 hours, or you rent it for one person or 100 people, you will be paying $100 no matter what. So we start out with this one by just saying, hey, it's $100 to rent, and so I go ahead and say plus 100. It is also an additional $8 per person, which we've already defined people here as n, so that would be $8 per n. So I write that, 8 times n plus 100. Now this next one says the cost of 36 people. We know how many people are going to be there, and so I can go ahead and take my expression and I can substitute in the 36 for n. So I do that. I'm going to go ahead and erase the n and put a times 36 there. When I do 8 times 36 plus 100, I get $388. So it'll cost me $388 to rent this ice skating rink for 36 people. Number 8 says their Ender has $365 in his savings account and spends $32 per week. We need to define a variable. So in this one, I notice that weeks there, it says per week. So I'm going to go ahead and say the number of weeks is our variable. The amount in savings after W weeks, and the amount in savings after 9 weeks. So I go ahead and take some information here. He started with 365 and he's spending money, which means that we take the 365 and we subtract the amount he spends every week, which is $32 times the number of weeks that he does it. In this case, we take 9 as our number of weeks, so I write out my problem. Instead of writing times W, I'll go ahead and write times 9, and that's called substitution again. So I have 365 minus 32 times 9. 32 times 9, I get that answer, and then I subtract it from 365 for a grand total of $77. So after 9 weeks, he'll have $77 left in his account. Alright, so try number 9 and 10 on your own. Go ahead and see what you can do there, and once you have that finished, good luck on your homework. If you have any questions, let me know. Have a great day.